All right, good morning. So this should be Wednesday, and we are here with the sub. Should have spent some time working with someone else in the class, maybe going over these three problems. I'm just gonna go over the solutions briefly. Number 3, Jack and Jill. They are standing 10 miles apart. There is a 35-degree angle here, 45-degree angle here. You are looking for how far the ship is from Jack, so that's this distance here, x. Because you know all three angles in the triangle through triangle sum, you can use this side and that angle opposite to set up law of sines, and solving you'll get 7.2. For number 4, you've got angle of elevation to the peak of a mountain. So here's my attempt at a mountain is 35 degrees. Susie, who's 1,200 feet closer, there's that distance, sees the angle of elevation at a 42-degree angle right here. And the question is, how high is the mountain? And so that's this height. Here's the perpendicular, so this was my mountain. Well, so if we look at this, if this is 42, this angle here is 180 minus 42, that's 138. And we can solve for this side here, because if you know this angle, you can find the side opposite. You have this triangle sum, side opposite. So set up law of sines, solve for A, and then look at the right triangle here, use A. And this h with your 35 degrees, that's opposite over hypotenuse, h over a, plug it in, and you get 3,779 feet. All right, last but not least, number 5, we've got a satellite orbiting Phoenix, LA. You've got angle of elevation from Phoenix is 30, from LA is 75. The distance between the two cities is 340 miles. You can solve for this angle using triangle sum. That way you have an angle side opposite. You're trying to figure out what this distance here is from LA to the satellite. And so you just use law of sines, 416 miles. All right. For the warm-up today, law of cosines. You should have solved this, and again, it's not about drawing your triangle to scale. It's mainly about looking at what you have and what you can use. So this is triangle A, B, C as given. Triangle A is 48 degrees, angle C is 63 degrees, and we're trying to find A. They also gave us side C is 10. So here you have an angle side opposite, which means you can use law of sines. You don't have to use law of cosines. Sine of 63 over 10 equals sine of 48 over A, and you can certainly set it up upside down. And what we're going to see is we have 10 times the sine of 48 divided by the sine of 63 if you solve it algebraically, which gives you 8.3. And there's no units, so that is it. All right, moving on with the notes that we didn't get a chance to finish. We talked about the patterns for law of sines. This is just isolating cosine of your angles. You can do that algebraically, or if you're good memorizing, I suppose, memorize those. What we're looking at here is just moving forward. What we are going to see is, problems where maybe you have to start with law of cosines, maybe you don't. So we'll just kind of have to pay attention. Remember, for law of cosines, that is side, 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 and also side, angle, side. And so it's really about knowing what information is given and what configuration these guys are in. All right. For side, 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 always start with the largest angle first, because inverse cosine will give you an obtuse angle. Number 3, we have a cruise ship and a freighter leave port at the same time and travel straight line courses, one at 30 kilometers per hour and one at 10 kilometers per hour. So here is maybe the port. you've got the cruise ship, and you've got the freighter. Let's call that F. So the cruise ship is going 30 kilometers per hour. That's not a distance, that's a rate. And the freighter is going slower. That's that thing that carries all those crates that you might see travel under the Golden Gate Bridge. 2 hours later, they're 50 kilometers apart. So this distance here is 50 when this gets multiplied by 2 hours. Cross off the hours. So that's 20 here, that's 60 here. Okay. We are trying to find the angle between their courses. That would be this angle here. Let's call it angle P. So you can see we have all three sides. It's a side-side-side case, which means we have to use law of cosines. All right, so we will set up 50 squared. All the way at the end is going to be cosine of angle P, but we're just going to leave it like this for a second. We square the other side, 60 squared, 20 squared minus twice their product times the sine of the angle, and that is angle P. I do not yet know what that angle measure is. All right. So next, we're to take 50 squared, the 60 squared, subtract the 20, divide by negative 260, 20. Not with the cosine of our angle, and then we get the inverse cosine. So on the calculator, 50 squared minus 60 minus 20 squared, divided now by negative 2. Parentheses and negative 2 times 60 times 20 is decimal. Second of the answer is 50.332. And that is the between their courses. Basically between where they're going. All right, so that was our problem. And now what we'll do is take a look at another way of finding the area of a triangle. We're given three. There's another law that you can use. But honestly, if you're given three sides, you use law of cosines. Find an angle, and then you back to 1/2 side sine of the included angle. So if you don't want to memorize a formula, that's definitely a way to go. However, formula is not that bad. This is called Huron's formula. He came up with some semi-perimeter. Semi means half. The curve of a triangle sides would add the three sides, divide by, and then the semi-perimeter multiplies it to the difference of the semi-perimeter and each side. S minus A, S minus B, S minus C. Multiply all four those values, and then take the square root and that's into the area. So, for example, in this triangle problem, we have all three sides. You would first calculate the semi-m is just plus 8 plus 10 divided by, perimeter. 5 plus 8 plus 10 is 10 divided by 2. That's 23 divided by 2, which is 11.55. It's okay that it's a decimal. And then you're going to take 11.5, you're going to multiply that to the difference of 11.5 and each side. Take the square root of that, and that gets you your area. And so 11.5 minus 5 is, of course, 6.5. 11.5 minus 8 is 3.5. And minus 10 is 1.5. So we're basically going to multiply all these numbers. So 3.5 times 1.5 times 6.5 times 11.5 is a big number, and we are going to take the square root of that. And we get 19.8 for the area. Center onto tenths. Okay. All right. We're going to give you a few minutes to look at these problems, draw the triangle, and then we'll go over them.